The question that I wanted to investigate was, how does the drop height affect the recoil height of a bouncy ball? And in order to do that, I picked some different heights, so that was my independent variable. As you can see in this column over here, I have a whole bunch of different heights. And I wanted to see how the recoil height, my dependent variable, changed. One thing that I wanted to keep constant, I should have three constants in my, three controlled variables in my in each lab. One thing that I thought was really important was the mass. I didn't want the mass to change, so as you can see here in my data table, I have all 50-gram objects, so it's the same ball. One thing that's important to have on raw data is to have uncertainties for each of your numbers. So I'm just going to walk through where I got my uncertainties. This 0.1 meter, I decided that uncertainty because I actually had to go out to different balconies and stuff, and I thought that plus and minus 0.1 meter, so about 10 centimeters, I figured that was a good, fair uncertainty for my process I was doing. This 0.1 gram, I got that actually from looking at the instrument itself. So I got that by flipping over my scale and reading that it was off by possibly 0.1 gram. So if you use my scale in this class, you can use that value as well. And then my recoil height, I actually had more trouble finding the recoil height. So I said, well, I thought it could be off by about 20 centimeters, so I gave it plus or minus 0.2 meters. And oops, I need to add a meter in here, so let me do that for you guys. Another thing, that brings me to my next note. Hey, make sure you have units for each of your headings. So there you go, I have meters. Make sure you have units for each of your headings. So if you have one that doesn't, make sure you're strapping either grams, meter, if we're talking velocity, meters per second. Make sure you have that on there. Okay, so the first step that we want to do is get this into process data. So this is raw data. These are all the trials I had. As you can see over here, I changed my drop height 3 times. So I started with 5, I went to 9.3, and I went to 11.4. In a good lab, you should change it at least 4 times. So this isn't a good lab, and I'm going to show you how that kind of hurts us later on. If you did 3 and you got permission from me, that was okay. Sometimes you can't do more than 3. Very rarely you can't do more than 3. But in this case, I only did 3. So I'm going to show you one thing that we can do in order to process our data. Alright, so the first calculation that's fairly simple that pretty much all the labs are going to need to do is condense 3 different trials into one data point. So for example here, I'm going to focus on the 5 meter drop height. So over here we see all these are the same drop height. So I have 3 data points over here. We have the 4.0, 3.8, 4.8, and I highlighted them in 3 different colors. And we're just going to do just an average like you've probably done before. We're just going to take one of them, add it to the other one, add it to the other one. So we're adding all 3 of them together, and we're going to divide by how many they are. So I'm going to divide it by 3. As you see, we got 4 plus 3.8 plus 4.8 divided by 3. I get a value of 4.2 meters. Now, it's something really important to notice that all of these are to the tenths place. Okay, we shouldn't magically gain a whole bunch of decimals over here, so we want to keep those to the tenths place if we can. Alright, there's going to be something else that we're going to have to do this 3 different times because we have 3 different drop heights. So this is 5, we're going to have to do it for 9.3, and we're going to have to do it for 11.4. However, it's really, really nice because with IB standards, you only have to show this calculation once. So this is actually all I need to show in my lab for the average height. I just need to show it once. Alright, the next piece that we're going to do as far as processing is talk about the uncertainty value. So I have 3 points here. I need to have a discussion mathematically to talk about how much do my points vary. And that's really what we're talking about when we talk about precision. I want to know how close my points are together, how reliable is my data. A really, really easy data analysis we can do is, and to find the uncertainty value, is to actually take the max height, so the max value, and so if you're working with another thing, let's say you're talking about the time, and you did 3 times, you want to take your max time and subtract it by the min time and divide it by 2. So you're finding your range of data and you're dividing that range by 2. So if you notice my data over here, I'm going to grab it and move it over so it's out of the way of the little sign over here. I have 4.8 because that's my biggest value in my data set. As you can see, my numbers vary from 3.8 to 4.8. So my biggest one is 4.8. My smallest value is 3.8. So that separates by 1. I divide 1 by 2 and I get 0.5. Okay, so those are the 2 calculations that pretty much everybody is going to have to show, and I don't have to show it again for any of my other ones. No, I'm going to have to do it again, but I don't necessarily have to show that on my lab. Alright, now we need to make a process data table. So the difference between a raw and process data table, if you notice just the size of this one here, it's pretty large. We had 3 data points, and we had 3 different trials, so we had 9 data points, and we don't necessarily need to see all of that. I like to condense it down and get less data points, but maybe be able to make a stronger conclusion from those data points. So what I'm going to do is take my average value, which you see is in green here, and I'm going to write that into my average, what I call my average recoil height over here. So I have 4.2, 7.2, 9.8. Okay. Now I purposely didn't write anything into the top of these headings of my columns here because we have to have again a discussion about uncertainty and units. So here's kind of the rule of thumb. If you didn't do any processing with the data, like if you notice all of these numbers are the same, so I didn't really need to take an average, it's just 5, then I can use the uncertainty I used in my upper column, in my first column, what I decided what the uncertainty was when I dropped it. So what I'm going to do is just rewrite in my uncertainty from my original table, which was plus and minus, I believe it was 0.1 meter. Okay, I use the same scale, so for my mass, I'm going to go ahead and rewrite my uncertainty of my scale, plus and minus 0.1 gram. Okay, now here's the thing we got to talk about for the recoil height. We decided that the uncertainty of our trials actually varied because if you take a look over at our data table, we had a whole different range. For example, when we look at the drop height of 5, let me zoom it in for you a little bit. If you look at the drop height of 5, you notice that our data ranges by 3.8 to 4.8 by 1. But if you look at the drop height we did at 9.3 meters, our data only varies by 0.3. And so the data from 9.3, we have to treat it differently than the data from the previous one. So we actually have to do the calculation I showed you from the uncertainty 3 times and put those for each one. So let me zoom back down my table and let me put those values in and we can talk about those some more. Alright, so as you can see from our uncertainty value that I calculated on here, our first uncertainty value was 0.5. So I went over here and I actually wrote a plus or minus 0.5 in the data table next to our number. And since each of our uncertainties were different because of how good we maybe did the experiment, we actually had to write a different number. And I'm not going to show you what I did because the example calculation is done over here and I just use the same process. So now I have 3 different data points, averages, and I have 3 different uncertainties I got from doing the max minus the min divided by 2. Next step is to graph all of these. Alright, last step is to graph it, and there's some tricks. In order to graph it correctly, we always want to graph our independent variable, so in this case my drop height, on the x-axis, and you want to graph the dependent variable. In this case, my dependent variable was the recoil height. You want to draw that up on the y-axis. Make sure your graph takes up the whole page, and as far as your graph taking up the page, notice how my data is nicely kind of spread out over the entire page. There's not 3 clumps at the start and then the rest is just empty graph paper. Try to fill up your page. And the last thing we got to do after we get that nice and graphed, make sure, another note, to have a label on it. So I have meters for my y-axis, and I have meters on my y-axis, and I have drop height. I have that in meters as well. So my graph is going to create a meters versus meters graph. The last little piece that we need to do is to put our uncertainties in our data graphically. And that's super important because you want to be able to look at the graph and see which points are trustworthy, how trustworthy is your data. So a really easy way to do that is to add error bars. Alright, I just put a little picture of our process data table. In order to do this, all we need to do is just use our plus and minus values that we calculated from our averages, and to do that I'm just going to grab a pen, and you can go ahead and if you want to write your, like I made this graph in Excel real quick, if you are printing out your graph, feel free, I usually do, just write in your error bars by hand afterwards. I'm totally fine with that. But what I have to do now is then go plus or minus 0.5, and I have to represent that graphically. Alright, so I have, I counted on my left hand side, and I have 1, 2, 3, 4, 5 boxes. So I have 5 boxes, and I have, if I count 5, I go up 2. So I have 2 boxes, and 2 units. Right here is my 2. I have 2 units for every 5 boxes. So if I want to figure out what each box is worth, I'm going to divide my value 2 by my 5. That's going to give me a value of about 0.4. So that tells me that on the y-axis, each box is worth 0.4. And so my uncertainties, if you take over here, look over here, my first one is 0.5. So I've got to go do my best to go up about a box, maybe a little over a box, since a box is worth 0.4. So let me get a little bit smaller pen so I can get a little bit more precise with my tip here. So I got to go about a little bit larger than 1 box, and I'm going to make a little bar, and I got to go down about a box and put a bottom of my bar. Okay, so that's my first data bar. My second one, if you look over here, since it's 0.2, I only have to go about a half a box. So it's nice on this line right here, so I can go down a half a box. I can go up a half a box. There's my error bars on that one. Okay, I'm going to go to my last data point over here, and I got to go 1.4. Okay, 1.4. So if each box is worth 0.4, I have to go about 3.5 boxes. So I'm going to count. I'm about halfway in between this box here, so I'm just going to count 1, 2, 3.5, I'd say is right there. And I'm going to go up, so I got 0.5, 1, 2, 3, and I'm going to make an upper limit of my data bar. Okay, so let's look at this data real quick, and this is why we make error bars. Right away, graphically, I think you can kind of see, when I look at data, I like to look, okay, which of these 3 points do I trust more? Well, for me, I trust this one a lot more because it has a smaller range it could be within. This one over here, I see right away, those are huge error bars. Okay, my uncertainty for that one, I just think something maybe happened there. Maybe it was the way I collected it after it bounced. But this is just kind of a graphical way for you to represent how certain you are in your data. How precise is your data? And after we do that, in class we're going to talk about how we can then draw best fit lines with these error bars. That's going to come next. So if you've gotten to this point, that's all you need to do for class tomorrow, and we'll talk about it as a class. All right, good luck. If you have any questions, always feel free to email me. Miller_Kenneth at salekais.k12.or.us. Have a good night.